Hello everyone, this is Aisha and this is part 2 of the tutorial. I think we covered a chunk of the content in the last class. Why am I saying class? I'm sorry, like I didn't mean class. I meant the last part of the tutorial. And since I think that was a pretty hefty chunk of the whole content, like you should be able to follow this one pretty easily. And I think we stop right here. And if you follow what was mentioned in here in this specific section and this one, you should easily be able to follow what's going on in these functions. I encourage you to sort of play around with them yourself and understand ke ho kya raha hai idhar. And I think that would really help, like sort of, as I said, solidify your concepts. Just please make sure you go through this file, and especially if you're confused about pointers, just messing around with things can really help understand ki kaise things are working behind the scenes. And here, let's move on to the more important part, which is going to be used countless times in implementing your own assignments, which are arrays and dynamic memory allocation. So if we sort of define a new array like this, right now it's not giving an error because जो C++ की recent versions है ना, they allow variable size arrays, but essentially this is not really they're becoming C++ is becoming more efficient at handling memory leaks and memory itself. But I personally think for learning purposes, it's better to use the older versions of this specific language, because it's important to know what's happening with the memory that you access. It's important to know proper memory management and how to safely manage memory. And as we can see, a safer way to do that is constant size1. You define a constant integer which can't be changed, and then you assign it to the size of the array. And obviously, since we throughout the course of this specific semester, we will go through assignments where we need to dynamically allocate memory and sort of handle new cases as we at runtime itself. So dynamic memory allocation basically works that way, that through runtime or through the course of running your program, if you encounter any variables that you need to assign to an array, so how do you make sure the memory is being stored for that? Since obviously we have this at compile time, but we have this at runtime. This is being dynamically created as a program runs on. So what we do is that this variable itself can be changed by manipulating the variable throughout the course of the program. But when we need to access the array, what we do is we define a new integer point array, and we assign a pointer that points to the first memory location in this array. So the new operator is very important here. It requests more memory from the compiler. It requests that the computer hands to us more memory than it already did. But it's important to delete it after it's used to make sure you aren't causing any memory leaks, and essentially you don't finish up all your resources. And this is just a very basic intro into this. I feel like the only way you can sort of understand what's going on here is to make your own arrays and delete them, make your own arrays, delete them. And yeah, so here I think we're just going to complexity of pointers. How far in pointers can you go? Pointer to a pointer to a pointer to a pointer. It can go like as far as you want, honestly, but it basically sort of makes you understand really how well and deep pointers can go into like sort of aiding your implementation as well. And you can have pointers to pointers and pointers to specifically here in arrays, you have this is going to be, I think, covered later on as well. Yeah, right here. So pointer to pointers is very important concept in multi-dimensional arrays. So you can essentially, extract this for as many dimensions as you want. So the first instance here, if we look at it, the multi-dimensional array has been sort of defined at compile time already. We know the size of it, we know what elements go into it. But how a multi-dimensional array works is you have a pointer location here, and you can have sort of a pointer here and a pointer here and a pointer here and a pointer here. And this basically points to, wait, let me draw this out so it becomes clearer. So you have a pointer here and a pointer here, and you can imagine this as a row, or especially the first row of the array. Now this pointer is sort of pointing to just for visualization's sake, if we, how do you make a, okay, this is very tough actually, but let me just draw it. Actually, that's much better. So here we have a pointer that points to another sort of array, and we have a pointer that points to another array, and so on, and another pointer that points to another array. So this way we can have multi-dimensional arrays. And this is specific for the 2D array. So we have a pointer that points to this first location. So obviously row, column. And this is a very simple sort of visualization of how 2D arrays really work. You can extend this visualization to any sort of dimensions you want. But yeah, this is the generic sort of explanation of how we need pointer to pointers. And you can see this here as well, that if you define an array pointer right here with constant size 10, you revert through all of these as int from 0 to int 10. And then for each of these specific locations, you assign them a new sort of int array. So what you do is basically you go through a list of 1, 2, 3, so on. Then while you're here, you assign it a new pointer array, right? This is what we're doing here. And we're doing this for each of the values in this loop. So essentially what we'll have is an I by 10, which is 10 by 10 sort of matrix. And let me just clear out these drawings. This would have been much easier to do on a whiteboard, honestly, but since we're constrained with the online setup, I hope this is as clear as I can make it. My point is that the pointer-to-pointer approach is obviously very important in multidimensional arrays, and this is one of the biggest uses of pointers itself. Okay, once you're going through an implementation of your code and you come across something that requires you to have a lot of pointers and a lot of pointers pointing to pointers and a lot of those pointers pointing to new pointers, since you need multiple arrays to store everything. So what would you do at runtime? Obviously, you can't declare it like this because this is constant size, right? But your variables are changing according to your inputs. And especially what we learn in data structures is obviously we can't really anticipate how big our inputs can get. So to handle these cases and to obviously more efficient memory management, we have pointers coming in to save the day. And we can see this here as well. And this is also a way of accessing the array. You can go over this. This is very easy. Triple pointer aap bana ke, first instance pe, you make a new int pointer for 10. For every iteration of this, you assign ke is specific value pe ek aur pointer aayega, phir us specific value pe for this here, you get a new int of 10. So this is going into triple, obviously, dimensions. So triple pointer here points to a double pointer here, which points to a 2D array. So यहाँ पे 2D array की सारी implementation आ गई है. So this is going to be very clear to you once you actually go through it yourself and play around with it. And we also, just to end off things, we can also see that as we are sort of assigning new variables, jitne aapke news aa rahe hain, utne hi deletes ho. So make sure for safer memory management, if you're initializing a new sort of array, make sure you have a delete function to delete it at the end. And I think this was meant to do that, but this was giving me include errors. So yeah. So I hope that this made things clearer. I can go, and I would really like to go over this specific part of the code in detail overview with in my office hours or sometimes on a whiteboard. I feel like the online mode of instruction really does hamper the way you learn about pointers. You really need a whiteboard and something to draw on. But I hope this would have given you at least like a basic sort of instinctual understanding or intuition about how pointers really work in C++ and why do we really need them. And you'll be coming back to this functionality and pointers and the basis of pointers a lot. A 2D pointers is honestly like the most you'll be covering in this specific course. Very rarely you'll have to deal with these sort of cases, but don't be alarmed. This is very easy. It just looks very intimidating, but it's not at all. And we can discuss this on Slack or in my office hours at any point. So I hope you like this tutorial. This is my first recorded one, and please be kind. And yeah, have a nice day. Bye bye.